Welcome back to the Ground Truth track at B-Sides Las Vegas 2016. I just wanted to take one more opportunity to thank all our sponsors because we couldn't make this happen without them. Please visit their booths out in the chill out area. Let's see, we're live streaming and recording this, so please turn off your cell phone ringers and whatnot. And please don't stand in the back because it's a fire lane. Up next, we have Layla Powell, who is a security data scientist at Panacea.
Thank you. All right. Thanks. Thanks. So I'm sure many of you have heard the term data science appearing more and more in an InfoSec context. And at the moment, as we've heard from some other speakers already, the focus currently seems to be on machine learning. Now, machine learning is a great family of algorithms and can be really powerful, but that's all it is. Unfortunately, we seem at the moment to be missing any coverage of the broader discipline of data science. This can be problematic for a number of reasons. First of all, similar to the talk we heard just before, people can get taken up by the hype of advertising around machine learning and just think it's a magic bullet for all their problems if they don't understand the work required before and after to make the solutions robust. Also, people maybe think that they can just start applying machine learning algorithms ad hoc on data without the experience to handle the data properly. But for the purpose of this talk, I want to focus on one of the other areas, which is the fact that we're not spending any time looking at data science as a discipline means that we're missing out on some of the benefits applying the discipline of data science to InfoSec can actually bring. In the last year, I've been working with financial services companies, trying to help them to bake in a data science approach to their data analysis in InfoSec. In particular, we've tried to help them with a couple of problems. First of all, communicating the data. It can be hard in InfoSec because there's lots of different stakeholders to get everyone to agree on what the truth of the situation is. And in that case, you then lose trust in the data analysis. So today, I want to talk to you about why data science is a discipline and what that involves, and look at how applying data science as a discipline to InfoSec can tackle some of the challenges that I've seen people face over the last year. Okay, so data science is discipline. Essentially, what I mean by this is it's a way of doing things. There are principles that govern how you should do stuff. It's not just a bunch of algorithms that we just throw at things. Data science, like many professions, is often misunderstood. People have one idea of it, but actually when you get involved, there's a lot more to it. And I'm sure those of you that are more on the InfoSec side in the audience can sympathize with this problem. So let's talk about the principles of data science. I've broken them down into three areas. And the important thing here is that they all build on top of one another. So the first one, data exploration and preparation, is required as the foundation for everything else that comes afterwards. So I want to give you a little bit more information on each of these areas. Okay, data exploration and preparation. This involves a series of principles. The first one is understanding what questions can be answered by your data set. So if you take any set of numbers, you can look at the distribution, you can calculate a median, you can do anything to it, and some other numbers will come out. But you need to understand what information is contained in the data and whether the question you're asking can actually be answered. The second one is domain knowledge, and this was touched on in the first talk this morning, suggesting that sometimes data scientists working in security might lack the domain knowledge to do the work. But actually, we should be getting this from the data. If we understand and work with the data properly, we can learn what we need to know to answer the questions from the data set, but we have to be careful to do it thoroughly. The next point is taking a look at the metadata. So by this, I just mean data about your data. When we take a set of data, say from a database, we don't just assume all of it's valid. We want to look at the timestamps governing when that record was updated. where it came from. Is it still valid now? Was it relevant 6 months ago? Can we still use it? The next point is around quirks in the data. At some point, whichever database you're reading from, you're extracting data from, was designed by another human who might not have thought exactly like you do. So when you export data and start to work with it yourself, you have to be careful not to make assumptions about how that data is structured, how it's updated, and how it's stored. Otherwise, it can lead to misunderstandings, misinterpretation. Then we need to think about completeness. This is slightly related to the first point, what questions can we answer? We need to think about, if we're looking at a population of users or assets, we need to really think about how well that population is represented in the data set we have. If we only have 10% of our assets in the data set, any conclusions we draw won't really be valuable. And finally, I've thrown in simple stats in here. I think this is often overlooked. People often want to jump straight to some really advanced algorithms. But actually, if it's the first time you've analysed a data set for something beyond its operational purpose, some basic statistics can be really valuable and reveal quite a lot. And you should probably be doing it anyway to check you understand, you have a feel for your data before you start to do anything else. The next area then of data science is applying the algorithms. Now, you will have heard a lot of great talks at B-Sides today and tomorrow around some of the specific algorithms, machine learning, other stuff, how these things actually work. But today I want to focus on as I said, the discipline of data science and the things you have to be careful of when you apply these algorithms. The main one I'd say is understanding which algorithms are appropriate for, first of all, the data set you have. So if you want to apply a statistical test or a machine learning algorithm, you need to think, what does my data look like? Some things will assume a normal distribution. Do you have one of those? If your data set is skewed, are you applying the right machine learning algorithm to it? The next thing is your use case. What is the question you're trying to answer? And what is the appropriate algorithm to provide you with the information to answer that question? This is particularly important for in the scenario I'm talking about, which is not doing data science as a researcher, but actually working with an InfoSec team in a company. So we can't just look at stuff that's interesting. We have to look at stuff that's useful. So the use case and what we're actually going to do with that afterwards is really important. And finally, the other thing we want to consider is the level of accuracy required. So how accurate a number is appropriate? How much time do we have to reach that solution? We can't say we'll be 90% accurate in 6 months because the InfoSec team we're working with needs something a bit sooner. And finally, on to communication, which is possibly one of the most neglected areas of data science and InfoSec. A few of the principles then of doing communication well is, first of all, balancing what I've called caveats versus usability. So we'll talk about this a bit more later. Essentially, what I mean here is giving someone enough information that they have relevant context for their use case and the decision they have to make, but not giving them so much information that they're completely overloaded and don't know what to do next. Next, we need to look at the perspective on the data that's appropriate for the different stakeholders. InfoSec data has a lot of different stakeholders with different roles and responsibilities, and you can't show one plot to all of them to help them do their job. Then we need our insights to be actionable, something I touched on earlier. When we present results from the data, it needs to be something that someone can do something about. There's no point just highlighting a bunch of bad stuff and leaving them to it. It's not really useful. And finally, we need to be careful that the probability of someone misinterpreting the way we've presented the data is low. So our job as data scientists, and this is what you should expect from a data scientist you're working with one, is to make sure you understand what they've presented with you. They shouldn't just be throwing stuff over the fence and leaving you to get on with it. So I just wanted to jump back to machine learning again briefly to say, where does that fit in? So it's kind of in this algorithm section. And what I want you to take away from this slide is that if you're going to apply machine learning yourself, For example, if you enjoyed the first talk this morning, you'd like to have a go with some of those algorithms, and you're actually going to use what you find to make decisions, make sure you do all this first bit, all the data exploration and preparation. You need to do all that as well, and you need to be able to communicate the results. And secondly, if you're looking at tools, back to the kind of crazy vendor claims again, look at what data they tell you they need to have for their solution to perform as they've claimed. Do they need to collect data for 6 months, 9 months? Which data sets do you need? How clean does the data have to be? Because your solution is only going to be as good as the data it's built on. So today I'm going to focus on the bottom and the top of this tower of data science, simply because there'll be a lot of focus on other algorithms in other talks. And I think often we forget how crucial the foundations are and actually doing something with the data afterwards. So I want to talk through how we can apply these principles of data science to InfoSec, and I'm just going to use the example of vulnerability analysis. So I want to start off with the data bit, if you like, getting the strong foundations. Now, if you're analyzing vulnerability data, simply using the tools that were provided by your vendor, by the vulnerability scanner, so just logging into their web interface or using their reporting module, then you don't really need to worry so much about all this kind of data science stuff, because you're just looking at pre-created plots made by the people that built the database, right? So this should all be fine. It's when you want to do something beyond what you can do in that tool. And I've seen a lot in the last year, people end up exporting stuff in Excel and trying to do additional reporting. And the problem when you do that is you need to have some kind of framework and a way of handling that data. Otherwise you get into all sorts of trouble. So if you're happy with your vendor tool, then don't worry about it. If you want to export the data and do something with it yourself, here's how we can go about that. So starting with the strong foundations. So I want to kind of set the scene with an example problem that I've seen in the last year. So we talked earlier about how there's a lot of stakeholders in InfoSec. And in vulnerability data, there's a lot of stakeholders too. You can have the patching teams, the vulnerability manager, you've got the CISO, you probably need to report up to the board as well. And all those people need to pass on information about what's going on. So suppose your CISO has to report on the vulnerability situation to the board. And they've got a nice trend line here of number of vulnerabilities over time. You can see something's happened, right? There's a big spike. So we know the what, but we don't know the why. Just by showing this plot, if they have to go and defend this in a board meeting and say something about it, from this data alone, we have no idea what's causing this spike. So one of the key points is to make sure we actually measure something meaningful. In vulnerability data, we often start off seeing a number of vulnerabilities reported, whether that's in internal reporting, I've seen that, or you log into your vendor tool, that's the big number, the first thing you see. But there's a lot of complexity in this, so I kind of wanted to walk through what goes into that. So imagine now we're trying to help the CISO understand that trend so they can explain what they've seen, give everyone a bit of confidence so they're not panicking. We're going to have to understand what builds up to make this number. Now, if some of you in this audience might be very familiar with vulnerability data, so what I say next might be kind of obvious. But the point I'm trying to make is that anyone that's not working with a given data set day in, day out won't know all these hidden complexities. So if you're trying to communicate about your vulnerability data to your CISO who might not have been hands-on with the data, they won't know all these things that seem obvious to you. Similarly, if one of your colleagues that works in a different area of InfoSec, but you guys have got to work together, you might not know all the subtleties of their data. So I wanted to just break this down so we're all on the same page about the kind of complexities that can be hidden in those sort of trends in a basic number. The first thing I wanted to talk about actually was kind of naming conventions. So when I started working with vulnerability data a year ago, I was really surprised that two things were called vulnerabilities. So I know, if you're writing a bit of code, you don't want to call two variables the same thing. Same in algebra, same in a lot of stuff. So it turns out that, as many of you probably already know, a vulnerability is a flaw in software that has a unique CV ID or a unique vendor ID. But then if we're referring to an instance of that vulnerability on an asset, well, that's also a vulnerability. So you can get used to this, it's fine, but it's actually pretty confusing. And it sounds like I'm being a pedant, and well, I definitely am anyway, but there is a point to this. I was working with one vulnerability manager, and she would have to go to the CISO and explain the vulnerability situation. And you'd have these conversations where you'd say, right, we've got 32,000 vulnerabilities. But we've got less work than last time because we've actually only got 100 vulnerabilities. I mean, it just sounds crazy, and it's a really hard concept to explain. So for the sake of clarity, I'm going to kind of rename that and call it detections. So vulnerabilities are things with a unique ID. A detection is an instance of that vulnerability on an asset. And this actually makes kind of reporting on it and discussing it with lots of different people that don't work with the data a lot easier. So it's worth thinking about language as well as the whole maths and data handling thing when you're trying to communicate to people that aren't in the weeds of the data every day. So let's start to break down this number. So if you remember from the principles of data science, one of the first things we wanted to get was that domain knowledge. So we're going to start looking basically what this number means. Okay, we've got 32,000 detections. Let's break it down. We've got, say, 25,000 unchanged since the last time we scanned. So that explains the big jump we've seen on our original plot that we showed to the CISO. We've got a bunch of new ones, a bunch of reopened ones. We've accepted the risk on some, so that's gone away. We've closed a bunch. And this all adds up to make that number. Okay, that's fine, but we still can't really do anything with this. So let's break it down to another level of detail. So it now starts to get a bit more complicated. And in the interest of time, since this is the last talk of the day, I'm just going to focus on one branch as an example. Let's take a look at the new detections that have come in. It's a bit easier to read. We'll have some that have come in because we've got newly published vulnerabilities. So you've had, Patch Tuesday, a bunch of stuff has been released. You run a scan, okay, that's all now detected on your machines. You have some, actually, we've seen that will come in because they're from an old vulnerability that's been newly detected on your estate. So maybe this is something from 2012 that suddenly pops up on a bunch of assets. So that's potentially interesting. Now, as we talked about before, a detection is a combination of a unique vulnerability and an asset. So we've looked at the causes related to the number of unique vulnerabilities changing. What about the assets? Well, suppose you're also rolling out a program to scan more of your estate. So you now scan a new subnet. So there's more assets. So now you've got more detections of vulnerabilities. But that's actually a good thing, right? You're scanning more assets. You're getting more coverage. This is a good thing. We're not worried about that. Also, maybe you actually buy some new workstations, bring those online, even an area that was already being scanned. You've got more machines again. So again, this is feeding into this increase, but it's not something to worry about. So I think what we're going to focus on is the first two then, things related to the vulnerabilities. But before we go any further, there's a couple of other things we haven't done, which were from the principles of data science. So let's pause this here and check the validity of our data. So let's look at the metadata. So we had the 32,000 detections, and there's a bunch of timestamps in vulnerability data, which you should probably go in and have a look at just before we continue. So let's have a look when the records in the database that we've exported data from were updated. I've kind of picked 90 days as an arbitrary threshold. This is one of the complexities, actually. It's not clear what the cutoff is. When is data valid? And that will depend on what the use case is, how frequently you expect the data to be updated. But in this case, 90 days seemed reasonable. So we'll have most of the detections updated in the last 90 days. So you can say, fine, that's recent relevant information. Keep that. We'll have some that haven't been updated in a long time. And again, I've broken out for you here some of the reasons why, some of the complexity behind this number. So some will be detections that simply haven't been retested. Others will have old update times because the asset they're on just hasn't scanned. And then if we again follow on the left-hand branch, those that haven't been retested, why is that? Now we get down to real kind of practical reasons. Maybe there's been an authentication failure. So some vulnerabilities you require authentication to test them. So if that fails, we can't update the record. Maybe the test hasn't been able to be replicated. You have to replicate the exact conditions to retest for the vulnerability. So if you remove a bit of software, maybe they couldn't do the test again. So there's, again, just the complexity of assessing whether the data is valid and making decisions about what do you do with things that are on assets that haven't scanned. I mean, you don't just want to be deleting information about vulnerabilities. So there's a whole kind of issue around this, what the right decision is. In this case, we were going to focus on the new detections. So we're in this side of the tree diagram, so we're OK to continue. The next kind of word of warning, I guess, is around the data quirks I mentioned earlier. So when you're exporting the data, and you see something called last scan date, you think, great, I'll just stick that in my my code, I'll use that, plot some graphs, that'll be fine. Do you really know what a last scan date means? Is it well documented? Possibly not. Is it the last time that there was a vulnerability scan? Or the last time there was a compliance scan? Is it when the scan kicked off, when it finished? Is it when the scan was last authenticated or not authenticated? Or the most recent of either of those? You can obviously work this out eventually, but a lot of time people will just take the first thing that seems sensible and go with it. And actually, we had a case where someone was exporting data and had got the wrong meaning for a timestamp, so wasn't updating any of their information. So, I mean, this can be really crucial when you start to do data analysis off your own back. So before we move on then, those are the kind of warnings around other things you need to check. So just to remind you where we got to, looking at new detections to explain that spike in the trend graph for the CISO, and we're going to focus on the things from some of the old and new vulnerabilities. This looks interesting. This appears to explain that spike. So the next thing we want to move on to is how we might actually communicate this. So we're going up to the communication part of data science now. We're not applying any complex algorithms, as I said. We're just getting some initial value from some simple metrics. Now, I think communication has been one of the biggest issues I've seen people face. I touched on it before. There's a lot of stakeholders. They all have different areas of expertise. Someone's dealing with vuln data every day, other people aren't, and the same applies for all the different controls. And it can be really hard to get your message across. So I wanted to kind of take a look at this. It's basically what we call the data flow in InfoSec. So you're going to start off down the bottom with your sort of tactical data. So this will be everything from your logs, your controls. And in our vulnerability example, this is going to be our 32,000 detections. We've got 32,000 data points down this end. Then as you move up to sort of operational data, so maybe you're kind of vuln manager level now, that's going to be condensed down. The vuln manager is probably going to be looking at, I don't know, histograms of age of detections. So they can see what needs to be patched next, how they're doing, keeping in policy. So we're going down from 32,000 data points, the error is getting smaller, down to maybe, say, 10 bins in histogram, compressing the data. And then we move along to strategic data. So this is going up to the level of the CISO or even the board itself. And this needs to get even more compressed. In fact, one InfoSec team we worked with had, at the bottom end, they were producing maybe a sort of 15-page report. At the top end, they had a quarter of a PowerPoint slide to explain the whole vulnerability situation in the business. So you really need to compress this as you go along. And it's not just a matter of necessity. It's not just people trying to be awkward, make the data more summarized. It simply has to be that way, because as we go along this chain, we go up the levels of management, the responsibility, the remit of the person at each level gets much broader. So on the tactical level, those 32,000 detections, maybe a patching team. There'll be someone working on the patching team, maybe for Windows, maybe just for the UK. So great, they can have all the raw data. They need it for their job, and that's all they're focused on. When we get up to the top, you'll have your CISO who needs to have an eye on all the controls on their estate across all global regions. She's never going to have time to look at the raw data from all of them. And what's more, it's not her job, right? Someone needs to have made a decision before that. So what data we show someone is essentially based on what they need to do with it. And this is really tricky because it comes down to one important balancing act, which I mentioned as one of the principles at the beginning. This balance between caveats and usability. So you need to provide someone with enough information to do their job, but not so much that they don't have time to look at it or they can't interpret it properly. And I think this is one of the big challenges of trying to get to data-driven decision-making in InfoSec is this flow of information as it goes up and giving people the appropriate level of information to do their job and recognizing that not everyone needs to have all the details at every time. So based on that, what we can see is that we need different perspectives on the data for different stakeholders. And what data scientists should be doing is taking some data, analyzing it, and then packaging up the results so that they're really usable for the person's use case they're trying to solve. But when you do that, when you make something really great for one person, it's not so great for the other person. That's okay. But I would say as a kind of word of caution, if you see some analysis in the press or, I don't know, being shown to someone else in your team that's at a different level, and you think, that's too simple. Where's all the really intricate details? Just think, was that analysis intended for you? If it wasn't, you're probably not going to like it. You're probably not going to find it useful. Probably be annoying. Like, I'd love to see all the all the logs, all the raw details. But the person that's been presented to doesn't. They don't have time to look at it. They need to make a decision. What's important is that people get the right impression of the data, the impression you want them to have. Say, the outcome is the right one. And often by giving people all the information you want to give them, you get the wrong outcome because you've just given them a bunch of logs and they're like, what the hell's this? So effective data science will be pretty targeted, is what I'm trying to say. So let's have a look, going back to vulnerability example, let's have a quick look at the different views that different stakeholders will have on vulnerability data, so you can see an example of what I'm talking about. So for a CISO, as I mentioned before, they have a broad view. They're going to be looking across the globe, and they're probably going to be comparing how different business units are doing. In fact, they are comparing because this is what people we work with typically look at. So some important differences. We've gone away from raw numbers now. We're looking at vulnerabilities per asset, so kind of a ratio, number of detections to number of assets. Otherwise, when you're trying to compare your different business units, a business unit with far more assets is obviously going to have far more detections of vulnerabilities. So if you look at the raw numbers, the biggest business unit is always going to apparently be doing the worst. So the CISO's job here is to make sure all the business units are performing well. So we look at a relative number of vulnerabilities, we compare across the regions, and we're looking at an overall trend. A vulnerability manager, for example, needs a totally different view. Suppose they're just working in the Americas, so this top bar here. They need completely different information. They need to kind of make sure that patching's being done on time and everything's being managed. So the kind of information they might prefer to look at would be something like this histogram where we have age of the detection, so how long it's been on your estate across the x-axis, and the number of detections with that age on the y-axis. So this is showing them if your patching policy was 30 days, you can see you've got a bunch, as everyone does, way past that policy, and plenty coming up. And then they'd probably also need an actual list of detections to see what vulnerabilities are there, to pass on to the patching teams so they can actually go and do something. And this is all the same data. But there's no point showing this to the CISO or the previous plot to the vulnerability manager. It's important, though, that we can easily go from one to the other. So another of the problems I've seen is that people will have high-level plots, which when you break them down to the raw logs, the numbers don't add up. We seem to have lost some vulnerabilities. Someone's filtered them out. Someone's done some weird thing in Excel, and you can't get from the raw logs up to the summarized view and back down again. And that's crucial. Everyone needs to be seeing the same data. It's just been repackaged, but it needs to be the same. So the next point I want to make about communication is around how it's interpreted. So if you're a data scientist and you're plotting a chart, or you're an InfoSec professional, you use handling data, or you're showing something about your data set which you're really familiar with, it can seem really obvious when you make a plot what it's telling you. But all of us have to be careful that we have to put ourselves in the shoes of the person viewing that plot and understand how might they misinterpret it. And again, if you're a data scientist, it's basically your job to make sure that the audience has a low probability of misinterpreting. So an example would be, okay, I'm going to show an average. So one CISO would like to see average time of a detection on the estate before patching. Nice, quick measure, easy, get an idea, compare the business units. Another one we worked with was like, no, rubbish, I don't want to see that. That hides outliers. Show me the full distribution. So it takes a bit longer to process the information in that, but there is more information contained in it. So the question you have to ask yourself is, if you're going to show someone, in the first case, the average, is that guy aware that it masks outliers? Probably he is. But is he going to remember it? Is it going to be in the forefront of his mind when he has 5 minutes to check the report you've produced and has to make a quick decision on what to do, on which business unit needs to be contacted and told to improve their process? And this is again one of the responsibilities of data science, to make sure that the communication is clear and unambiguous. And it shows us that the way we present data is specific not only to the role of the person, are they patching team, vol manager, CISO, but also to the individual, especially in roles where people come from different backgrounds. So for example, the CISO role, some will be very technical, others might be more from a management background, and they might have different skill sets when it comes to understanding data. So we have to bear all of this in mind. The next principle to apply is that of actionable insight I mentioned. So as a data scientist, when you produce a plot, or as an InfoSec professional when you're producing your report, or when you're being shown something, you should ask, so what? What do you actually do with that now? And remember, again, this isn't about doing data science and research, it's about working with an InfoSec team that actually need to do stuff. So I wanted to take you back now to the original part we looked at, that trend the CISO was trying to understand. And we saw that seemed to be to do with new vulnerabilities coming in, old vulnerabilities coming onto the estate. Let's see what we can do with that. Let's take a look at a way we can potentially provide some actionable insight. So the trend we looked at before is on the left. We can see there's been a sharp spike in the last month. The CISO needs a reason to go and report to the board. And from the kind of analysis we did before, breaking down all the information, getting that domain knowledge, we saw that it appeared to be linked to the old vulnerabilities being reintroduced into the estate. On the right, if we look at those plotted out separately, notice we don't plot all those things from the tree diagram. That would just be, that's too many caveats, right? This is usable. We have in yellow the number of detections coming from old vulnerabilities being reintroduced, and in blue the number of detections coming from newly published vulnerabilities. There'll always be newly published vulnerabilities, but as you can see, this is pretty flat. This hasn't changed markedly in the last month. However, the number of old vulnerabilities has shot up, and one of the ways we've seen that can happen is if you have a kind of out-of-date standard build So you put that back in, it's got old software in it, you suddenly introduce a load of old vulnerabilities and you have to patch them again. So this is actionable. This hints at process. This isn't about patching all the time. It's about looking at other aspects of the data. Where are those vulnerabilities actually coming from? Maybe if we update the standard build, we won't have all this stuff coming in. We actually saw an example with some people we were working with, and an old version of, I think it was Skype had been rolled out. And you can do this analysis broken down by software type as well, and then you see all these older vulnerabilities coming in. And that's just poor process. You don't want to pass that on to your patching team. That shouldn't be there in the first place. So this kind of insight, this is a pretty simple example, but this is what makes something usable. The plot on the left gives an idea, but it's something like the thing on the right which indicates what someone should do next, right? Go and review your process, go and review your standard build. Yeah.
So are the old vulnerabilities that existed before that are now redetected in your own environment, or just vulnerabilities that have an old age that are newly detected in your environment? So there are new vulnerabilities too.
Yeah.
From past.
Yes, you could have both actually. Yeah. So the case of the standard build, there would be an old vulnerability that's new on that asset. But of course, you could also have, they could have been detected on your estate before. So when that standard build was up to date, things would have been detected on it, they would have all been patched, and now you're putting them back in essentially. So yeah, you can have both. Another one of the complexities, right? So that would be another avenue to go down to split this out further. Okay, so I feel like we've gone through the kind of framework of data science, for example, of vulnerability. We've seen the way to approach the data when you're handling it yourself, how to get some insight and the things to bear in mind when you're trying to communicate it. What I wanted to talk about in the last kind of section is going beyond your data set. So all this stuff we've talked about is just for one data set. And that's quite common in InfoSec, right? We have all these siloed tools. We look at this one, then we look at this one. But actually, once you have this kind of framework in place to make sure you're handling data carefully, handling it properly, and people kind of get on board, everyone's agreeing on the picture they're seeing, we can start to look outside the data set. One of the first things we should do next is start to think about the completeness of that data we just looked at. We've done all that analysis, but we haven't checked how complete the data is. So this circle represents all the hosts that we found in our vulnerability scanner database. That's what we use for all that analysis. If we look at all the hosts we have on our estate, represented by this grey circle, what we might find, and probably will find, is that there'll be hosts on the estate that aren't being seen by the vulnerability scanner. And unless there's a good reason, they probably should be. We also might see some hosts in this small section here that are in the vulnerability scanner that actually have been decommissioned, and we haven't cleaned up. No one's cleaned up the database. No one's purged the data. But the main thing we're worried about is this grey area. And the bigger this is, the less confidence we have in how relevant our findings of what's driving vulnerabilities on the estate are. So what can we do about this? Well, we can start to look in other data sets to see, to get visibility on these hosts. Now, it'd be great if there was a really up-to-date CMDB, but in my experience, that's not the case. So we can go to other data sets and use those. So what we've tended to do in the last year is get data sets that will go some way to helping us solve the problem we have, but are easy to access. Often, security teams don't own all their data sets. They could be outsourced, owned by IT. On some systems, logging might not be switched on to a high enough level of detail to answer the use case you want. So you have to be a bit pragmatic and get the data sets that will help you, but you can get quickly. Again, we want to get a quick return on investment so that people can actually do something with this data. So one of the things we've been using is AV data. AV and Vuln are both typically quite easily available. So what you can do then is we can essentially join the data sets together and look for hosts that are in both, which is the overlap. And in the case of trying to get a feel for how good our control coverage of the vulnerability scanner is, look for hosts that are only in the AV data. So this is this section here. And then we can go and see why aren't they in the vulnerability scanner. We also can start to work towards some kind of percentage coverage of our vulnerability scanner as a control. So whenever you look at data from your controls, you should try and understand the percentage of your estate that control covers. If it's a really low percentage, your conclusion is just basically useless. You should try and improve the coverage first, then do the analysis afterwards. So as with all the kind of machine learning hype, it's one of those things that like sounds really easy when you first mention it. Actually, it's really hard to match the data sets together. So in the vuln data I typically work with, you'll have an IP address, but often you won't have a host name resolved. Often there'll be no DNS name resolved. So then in AV data, you want to try and match it. But if you use the IP address, a lot of businesses obviously will have DHCP. So is it the same asset now? You can't check the host names because most of the time you don't have them. And okay, if it's the same IP address and the AV scan was an hour after the vuln scan, okay, they're probably the same. Or if it's 3 hours, or 4, or 5, 2 days, at what point do you make that cut? But you can actually do a pretty good first pass with any host names, NetBIOS names, for example, that you do have in the data. So it's not too, there's complexities, and that's probably, that host resolution is probably another talk. But you can do a good first pass. You can learn something from this data. And then to learn more, you can get more data. So maybe you can get the DHCP logs and start to see which assets are assigned which IP addresses. And at this point, you're really glad you applied that really solid framework of how to handle data and how to communicate it. Because if you hadn't done it, this is an incredible mess by this point. And the more data you put in, the harder and harder it gets to manage it sensibly. So building up that framework of data science and applying that to InfoSec data allows you to add more data sources in and build complexity without completely losing all the accuracy and trust in your data. The other thing I wanted to highlight is that once you start to get all this data and you're managing it well and you know what you're doing, why not use it for other things? So we can start to get a bit more context around what's going on with our assets, right? We can start to find, when we were finding hosts in lots of different data sets, we can start to say, how's that host looking in the vulnerability data? What vulnerabilities does it have? What's the situation in AV? What else is going on? Maybe what users are logging on? What software is on there? Have we had any alerts from other systems involving that host? So we start to get a lot more context that can make it easier to do some of the tactical and operational work. Another benefit is that if we start to bring in business context information as well, we can move towards having a wider view of security across the business. We can start to make it something that is more relevant for the board. We can get a bit more buy-in from the board, right? Because we're now starting to talk their language. We can communicate better with them. They can give them an overall picture of what our sort of exposure to risk is. So, the takeaway from this talk is essentially that, first of all, data science is more than just machine learning. There's a bunch of other stuff. There's a whole framework for how you can approach analysis. And if we can apply this to the way data is handled in InfoSec, we can improve the trust in and the communication of security data. The benefits of this, for those of you that are working in a tactical operational way, is you can get more context. You can know more about what's going on that might also be important when working out how to prioritize tasks to understand which are the riskiest assets. But possibly the most valuable thing in the long run is that we can start to provide evidence to management, to the board, that demonstrates how the work of a security team is lowering risk and helping the business. At the moment, the situation we're in is if nothing bad happens, then it's okay. So no matter how much work you do, there's no evidence to show what you're doing. Just nothing bad has happened. It's hard to measure nothing, right? So this way, you can really communicate to the board what's going on, what the security situation is, and finally demonstrate all the hard work the InfoSec teams are doing. Thanks.
Hi, I have a question slash comment, and you touched on the importance of looking at basic statistics. And for me personally, count is the fundamental stat that I look at first, because that addresses coverage. If you don't have good counts, your means don't mean anything. You can't establish statistical significance. So,
yeah, I think that's absolutely true. A lot of the problems I've seen is people, literally the numbers just don't add up. So people think they have X number of hosts, and you look in the vulnerability data, like we've got Y number of hosts, and then are you meant to be scanning these? Are you not meant to be? You have problems with simply numbers of vulnerabilities not summing to the total you expect to have, because people are exporting data in Excel and cutting it and changing it. So yeah, absolutely, there's a lot of value. Count stuff first, then try summing it, right? Let's look at a median. You have a much better feel for the data.
the other point is when you're looking for how people are trying to lie statistics, look for how they exclude data.
Yeah. So the exclusions is actually a big issue, and I think it's something that people often do unintentionally. So people will, I talked about if you're not an expert in a data set, right? And someone presents stuff to you, they might assume it's obvious to you that they've cut out things that haven't scanned in the last 30 days. They've cut out severity 1 vulnerabilities, because who cares about those? We probably should care, by the way, but that's not advice. And they'll assume, perhaps, that it's obvious those things have been done. And as that goes up that chain, as that flows through the level of management, no one knows those cuts have been made, right? And then if that person leaves the business, the next person comes in, they're trying to replicate that reporting, and the numbers just don't add up. They don't know that guy chopped out those older detections or made that cut. So absolutely, I think that once you get this approach working, you need to move to something that's repeatable then as well, repeatable and automated if possible, because then people can't start cutting bits and pieces out.
You may have already touched on it a little bit, but can you share a couple of common ways that, or common mistakes that you can make when kind of interpreting, analyzing data, potentially arriving at the wrong conclusions because, let's say, for example, certain data points are over represented, and therefore you kind of like, oh, the example you gave was, of course, North America is going to have the most amount of vulnerabilities because they have the most amount of assets. Do you have a couple of other examples that are like really easy to fall into, like traps and stuff?
I think it's a lot of it is just around making assumptions, actually. People will see, the example I gave around like the last scan date thing, right? People be like, oh, well, that's obviously the last time the scan started. And then they'll develop some really nice plot based on that and find out later that was actually the last time authentication failed or something. So it's about testing your assumptions about the data, actually. So, if you can actually run a test and see what happens when you change things, test your assumptions. Another example like that we saw was in a database, you would have, when you had DHCP, you would have an IP address used by a Windows machine. You get a NetBIOS name. Then a Linux machine would have that IP. And I would just assume, right, okay, that they're probably going to nullify the NetBIOS field, right? That should be a blank now. No, it stays there. That's how the data's stored. And if you had left that in and done all these plots based on NetBIOS numbers of unique NetBIOS names or something like that, they could be totally wrong just because you've assumed that if you built the database, you would have done it like that. It's actually the really simple stuff that trips people up before they even get to attempting to apply black box machine learning. Like this gentleman said, the count's wrong. Or someone's filtered something out in a spreadsheet and not told you.
Great presentation. You're giving me flashbacks to VM programs, and a lot of the problems we had. But one of the things I had was with communication, and I
Yeah.
think you kind of touched on that. So I wonder if you had any lessons learned in two different areas. So I've been asked, when I was doing it for metrics that weren't really very good to look at, like percentage of severities in your environment. So, if you clear out all your level ones, like you said, your level fives would increase in severity when actually the security would be decreased overall. So
Yeah.
that's one example. And then, and also went like impromptu data. So, taking your data at times of the month may significantly decide how your data looks, like after patch Tuesday or whatever. So
Yeah.
I was wondering if you had any suggestions or lessons learned around those two areas. So.
Yeah, I think so to start with the time analysis thing, I think that's something you absolutely have to be careful with. So, for example, one of the things we do when we first go in and start working with people's data is try and match to their existing reporting, right? A bit of validation. And you can find that if you export from a database on a Monday one week and then export on a Tuesday another week, your data doesn't agree. So it's important to bear that in mind. It's also important to think about whether you want to look at behavior in kind of like a rolling window, or if it's the current status that's important. And that depends, that everything is quite dependent on what the use case is. So I think it's being aware of that and thinking about how it might impact on your results. Remind me your other...
The other one was on kind of funny metrics being asked for, like,
Yeah.
you present your data in vulnerabilities per host, which is an excellent NIST metric, but, I've been asked putting it in a percentage as a pie graph, which is horrible.
Oh, God, yeah.
Beyond just the pie graph.
Yeah.
Percentages is not an accurate way to measure it.
Yeah, I think this is the thing. This essentially comes back to the kind of breakdown, right? The vulnerability stuff is you have to see what's feeding in. I think you have to try to guide people. I think just doing data science is sometimes a bit of an education piece. So in the same way that you can take guidance off InfoSec professionals around the way that data is useful to them and what they need to do their job, they can hopefully take guidance from data scientists around the best way to present data. And I think if you explain to people why they might actually be misleading themselves by showing that, and give them an alternative and show them a valuable alternative that's useful. So maybe looking at, like as you said, like a ratio of things instead of percentages. I mean, percentages can be fine. It depends. It depends what you're doing, right? The coverage one can suffer as well, right? So, your coverage can be really good, and you can bring more assets online, and then it takes a while for the scanner to go and find them. So your coverage plunges. It's about having reasons, about being able to explain the differences.
And how to explain sometimes an increase in vulnerabilities may actually be a decrease in your risk if you added more hosts or...
Yeah, exactly. So that was the tree I had before. That was the point. Some of the changes are actually positive. You've rolled out your scanner to a new business unit, and I've got loads more vulnerabilities. So it's about, I think, there's not one metric, right, that's going to give you the whole state of vulnerability. So it's about potentially having a bunch of simple metrics that are kind of that will flag up these areas. So they'll flag up things around process. So looking at age of vulnerabilities and how that changes, whether they're old or whether they're new. You start to look at, as I said, standard build process or other things. Also looking at tracking the number of assets. So I think one thing I've been working on is actually, as a complement to looking at number of vulnerabilities, is looking at how the number of assets on the state is changing. And you can correlate that, right? So if you have a set of metrics around assets, you can see if that's shot up, you're going to expect a boost in your vulnerabilities. So it's around grouping together metrics, I think, that inform each other. And for sure it's challenging, because especially with vulnerability, because there's so many factors that come into play. But I think anything is better than the kind of current situation I've seen, where it's typically a number and a trend and no insight at all. Yeah, exactly.
Hi, thanks. You have a great presentation, and having done this for a while, I just have a lot of questions, but I think one of the biggest ones I had was, and ones that I grapple with a lot, is the last bullet you have effectively here. So how do you tell, the business ownership, the leaders, the money people,
what risk means to them. Is your definition of risk just lowering the number of vulnerabilities? Is that it? Because the risk to them, I think, is something else, and it has a dollar
Yeah.
value associated to it. So do you have anything related to that ties in the entire enchilada?
Yeah, nice phrase. Yeah, absolutely. It's really complicated. For sure, it's not the number of vulnerabilities. Totally agree. That's not the point. I think this is something I'm working on with my colleagues at the moment. Actually, is looking into this in kind of how we can really estimate what risk is. That might be looking at that kind of host-centric risk, seeing how that plays out when you look at your controls across the infrastructure. But I think as a kind of first pass, when we're talking about these basic metrics that I've shown today, it's simply about showing, allowing the CISO to show that if he or she implements a strategy, something happens. So if they roll out vulnerability scanning across more of the estate, they can demonstrate they've done that. We have more visibility. So it's around educating the board on what security is doing as well, I think. So it's being able to show an outcome of work you do. And I think one of the examples of vulnerability that can be problematic is if you take a really simplistic view and you just see an increasing trend. If that CISO, in my example, had gone to the board and been like, oh God, look at this spike in vulnerabilities, people will kind of infer things that aren't true. Maybe they're like, what's the patching team doing? This is rubbish. And actually, you've actually improved coverage of the vulnerability scanner across your estate. You've actually done something good, and it represents as something bad if you have overly simplistic metrics. So simply repackaging the data in a way that gets insight, the proper insight, and gives a reason why things are changing. And the CISO can go and point to and be like, you know what I'm going to show you? I'm going to show, okay, vulnerability has gone up, but that's great because we've got awareness of these now. We didn't know these were here before. That's a totally different story to like, there's a big spike. I've got no idea. So I think it's providing reasons, providing evidence for what you've done, and then eventually working up to I mean, like you say, $1 million question, right? Is getting a measurement of risk to the business. Okay, thanks.